Hello. This is going to be an experiment where I take a recent exciting paper, this paper on introspection from Anthropic that came out a few days ago, that I kind of vaguely know roughly what's in it, but I've not actually read it. And I try to read through and figure out what I think of it, how much I buy it, which bits seem important versus maybe BS, and attempt to dictate my thought process as I go. I have no idea if this will be engaging viewing or not, but hopefully you are down to experiment. Alright, so maybe so we're all on the same page, we should begin by just going through what I currently roughly think this paper is about. And in the interest of being as realistic as possible, let's just read the tweet thread, because, that's how everyone reads papers nowadays. Alright, so size of inspections in LLMs, kind of sounds like clickbait, but maybe there's something interesting here. Can language models recognize their own internal thoughts? So, yeah, so I think this diagram is like a fairly good diagram for kind of giving the gist of what this paper is about. So, as I understand it at the moment, the key thing in this paper is basically saying, well, we can steer models by adding a vector that corresponds to some concepts inside of them, and this often seems to have approximately the effects on the model's behavior you might think, e.g., you add the all caps vector and it talks in all caps. But the question they're trying to investigate is there a difference between this and a natural thought in the model? And in particular, does the model seem to have some kind of introspective access to this? It's pretty obviously the case, in my opinion, that adding in a vector is going to be different from the model naturally having the thought, since if nothing else, you typically have to add in the vector with a pretty big coefficient that is fairly unnatural in terms of what the model would typically experience, but by default, I also expect models don't really understand what's happening inside their head. So I find the core claim here kind of interesting. In particular, this idea that the model, when asked, is there something weird in your head, is like, I noticed what appears to be an injected thought related to the word loud or shouting. And they also conveniently have a control where they don't do steering and observe that the model doesn't say, I have a thought injected in my head. And I actually know what the middle bit is about. What's the middle bit about? So, okay, so it looks like there's a kind of two-turn setup they do to exhibit this behavior. First, the user gives a prompt, which is kind of explaining what steering is about, and yeah, being like, you might have a thought injected, and this is kind of what having a thought injected means. The model is made to say okay, which is a bit suspicious. That's just not normally how models react to things, I think. They often say more than like 2 tokens. And then there's a second turn where it's like, okay, let's get started. Trial 1, do you detect an injected thought? If so, what is it about? And then, so the natural question to ask now is like, what exactly does it mean that they get these observed differences? So, a couple of questions that I will generally try to ask about any paper like this. Well, first off, this is a qualitative example. It's just like a concept, a prompt, a response. I have no idea if this is representative of like the general phenomena, or if they just cherry-picked one random example that looked really good. So that's like a key thing to check. I mean, Jack Lindsay, the first author, seems great, so I would be shocked if that is in fact what they did, but like, I should check. The second thing is I'm kind of surprised at the level of complexity in this setup. Like, it seems like you know, by default, you do one turn. It's a bit odd they're doing two, and it's particularly odd they're doing a prefill. It's not super weird that they kind of explain the idea of injection in the prompt, since it makes sense that these models are like, yeah, it makes sense that these models probably don't really understand the idea of injection or introspection off the bat. Maybe, I'm not really sure. They'll have been trained on papers that include a bunch of interpretability papers, but having things explained in the prompts is probably helpful, and the result is still surprising regardless. So I'll give them a pass on this one. But I am pretty interested whether they've done ablations. Like, what if they let the model respond naturally rather than doing a prefill? What if they do a single turn thing rather than a two-turn thing? And I do find that a bit surprising. So yeah, the final thing is just, I don't know, what are my guesses for mechanistically what's going on here? So, like, one thing that would not be super interesting to me is if the model was saying, if, say, they pre-filled the model, like put words in its mouth to say, I notice an injected thought about, and then had it continue from there. Because they've added the all caps vector with probably quite big strength. It's probably in some sense dominant over other concepts the model might have in its head because of this artificial nature. And so when it's just reaching for a word to include, well, it's not massively surprising that it would go with some words related to this concept. And then once it started saying words related to this concept, saying other things that follow on from that seem not massively surprising. So kind of conditioned on the model saying everything up to like the word here and then the quote mark, it filling this in with loud is like not incredibly surprising. I predict that this probably happens on a bunch of models, though the conversion of all caps to like the word loud is like a bit abstract. I mean, I'll note that it puts loud in all caps, which is not what you would like naively expect from this sentence, suggesting this is probably also partially just the B in all capsness manifesting. Like, syntactically, you'd expect it to be lowercase, because just it's a word, it's not actually shouting the word in the context of the sentence. So this bit is not actually very surprising to me. But saying, I noticed that I have an injected thought, I think is surprising. I don't have an obvious, naive, mechanistic explanation for why injecting a concept should mean that the model responds differently to the question, do you have an injected thought? And obviously, models are suggestible. They might just always say, I have an injected thought, but this figure seems to be claiming that's not the case, because they've got this default response. I'll take them at their word. So, to me, this is kind of the interesting mystery. Like, what is happening? So, first, just as an empirical phenomena, is this a legit result? Does this hold up? Does this have a good sample size? Etc. And, like, which models does this happen in? Blah, blah, blah. But also, mechanistically, what could be going on that would cause the model to respond differently to the "do you detect an injected thought" question? I can see boring hypotheses, like maybe just being thrown off distribution by having a vector be added makes the model act a bit differently, and in this particular context, acting differently means having a high probability of saying, I notice an injected thought. And like maybe in general, if you ask the model Boolean questions, adding any vector will sometimes change its distribution of answers in systematic ways. I think this is probably false, but like it could be true. And important null hypothesis to check for. But all right. So let's go back to skimming through the thread. So they're saying, they inject the concept, and then they ask Claude, do you have this thing? I do also appreciate that they are creating these vectors by just subtracting activations on 2 prompts rather than using an SAE. I appreciate the low-techness and pragmatism rather than being unnecessarily fancy. And okay, so they're just giving like a couple of other examples, including a kind of range of interesting conceptness, like recursion, on some coding related things. This one is kind of mildly surprising to me in that it's just not obvious to me that the like massive salient difference between these 2 prompts is recursion. It's also, it's got an if statement in it. It's got an equality check, things like that. So like, I don't know, it isn't a priori obvious to me that recursion is the concept we would expect to happen. But conditional on that happening, seems kind of plausible. I think I'm not super surprised by the fact that it works on abstract things like recursion, in addition to simple things like dog. We kind of already know from, at the very least, the sparse autoencoder literature that models have a bunch of things like recursion represented as vectors inside of them, so this particular one doesn't seem super surprising to me. So like, given that they have a recursion vector, and given that in general models notice when they have a thing injected, I predict that it would be able to do something like this. I mean, it would be kind of an interesting test, if any viewers feel inspired, to kind of make a model say all of the sentence up to the quotation mark before recursion, and just try adding in different concepts, and even on a comparatively dumber model, and see if it can produce the words that represent the concept, even if fairly abstract. I predict that even on only moderately sophisticated models would like probably work. But yeah. And love it. They have a tweet acknowledging that this is not a universal result. I appreciate the good epistemic standards. This is interesting. We show Claude introspects in order to detect artificially pre-filled outputs. What does this mean? So, all right, so saying, so, this is interesting. So if I understand correctly, they're saying, well, we got the model, we made the model say something totally irrelevant, bread, and then we asked it, do you mean to say that? And it was like, no. And then we injected the bread concept with pretty big strength, I think. I don't actually know what +8 strength means. My guess would be that if they are getting these vectors by literally taking a difference in activations, or like a mean difference, 8 is just literally the coefficient. But it's kind of hard to interpret. So, like, the question I'm thinking is, well, how big an intervention is this? Like, if the norm of the added vector is like 10% the typical norm of the residual stream, then times 8 is like 80% of the typical norm, which is kind of insane. If the vector is like 1%, it's like probably reasonable. Anyway, the result they seem to be claiming is that when they inject bread into the model says, I meant to say bread. They say retroactively. I don't know if I buy that, assuming this means what I think it means, which could be totally false. But like, so I presume they mean retroactively because they're saying, well, we kind of got to the end of turn 2 in the conversation and then went back and injected some stuff on user turn 1, but the model has not actually generated any tokens up to this point because this was a prefill. We just made it say bread. So, in my opinion, this is no different from injecting a concept on like the middle sentence of a 3-sentence user prompt or something. The model's just processing the whole prompt at once, and so there's no real notion of retroactive. And also, it could leak the thinking about bread kind of further downstream. Like, if you add this, say the middle layer, then in the layer after, the bread token would probably have gotten some information from that. 10 layers later, the bread token might be totally different than it would have been if bread had never been injected. So, like, even though the actual tokens are the same, I don't really know if I'd call that retroactive. But it's still interesting. It is, like, not at all clear to me that this should work. It's also not kind of totally outlandish, but I do think this is a legitimate example of introspection in the model. Like, I meant to say in a way that is dependent on the prior activations is kind of interesting. Is particularly interesting because my naive prior would have been that models generally will just post hoc rationalize most things they are claimed to have said and like aren't really designed to say not that they kind of like have a tendency to double down, though I imagine Anthropic has tried to trick Claude out of this. I don't know how much they've succeeded. Notably, it doesn't seem to have I was prefill injected in its hypothesis space over here. It's just saying, oh, that was an accident. I don't know why I did that. Lol. Yeah, we got treasures. Cool. Yeah, and I mean, I also note that the justifications the model gives are kind of ridiculous. Like, I saw it on tying their hiking boots, and it connected to the idea of seeking treasures. But I think this is pretty consistent with prior results on steering. I mean, I know anyone who's seen Golden Gate Claude, I think, has experienced some of the kind of slightly derangedness you can get. All right, so I'm not sure I buy this claim. So as I understand it, this claim is saying the model compares what did I intend to say against what actually came out. That is one explanation, but I could imagine there being more boring explanations, like the model just has a is this word out of place concept, and when there's something that is not related to what happened before, the this is out of place activates, and then this is out of place makes the model say that was an accident. But if the bread concept is present, then the this is out of place concept doesn't fire, and so the model goes with its default programming of doubling down, and the fact that it's been steered generally will make it kind of bread obsessed anyway. So it's like an interesting result, but I don't really know how to interpret it. And yeah. Yes. So this was a really weird result. So as I understand it, they basically tell the model, think about aquariums while you write the sentence on a kind of random task. And then they tell it, don't think about aquariums in a separate run. And then they look at the projection onto the aquarium concept, and it is higher when told to think. The y-axis here is cosine sim. I'm not entirely sure why. Typically, I would use projection or something, but cosine sim of like 0.12, while not naively seeming like that much, in a many thousand dimensional space is quite a lot. So the concept of aquarium seems like it is, in fact, present. Yeah, one rough intuition when looking at cosine sim could be if you square it, so here that'd be like 1.4%, maybe you can think of this as like what fraction of the norm of the overall residual stream is explained by the aquarium component-ish, maybe. So, 1% is like not that much, but also not trivial. So, but the important thing is the comparison, and yeah, it is kind of striking to me. I don't know what to make of this result. I mean, you could imagine some boring explanation, like the qualifier don't in the second prompt basically is inhibiting some attention that would be paid to this sentence versus if don't was not present. And the model is generally just attending earlier in the prompt, and this means that concepts present earlier in the prompt get carried forward a bit, proportional to the amount of attention. And if don't means there's less attention, then, or like, the model is instruction following, and it sees the think about, and it's like, I should think about aquariums. Or like, I should look at the sentence, think about aquariums, which happens to have the mechanistic consequence that it thinks about aquariums, but not in a way that necessarily implies intention. And I don't know. But it's kind of weird. I would not obviously have predicted this result, and I try to avoid being too cynical about results that I would not have predicted in advance. But also I try not be too cynical, because most results are boring, and in particular, most exciting, sexy results are boring. Because most results are not exciting or sexy. But a higher fraction of false results are exciting and sexy than true results. So the more exciting it is, the better the Bayesian evidence of being bullshit is. Anyway, anything else fun in this thread? This is a fun graph. So this seems to be comparing how well this works on various models. I don't know exactly what the graph y-axis is. I guess it's like, how often does it... What is the difference between the fraction of the time it says I have an injected thought when it in fact has an injected thought? Or possibly, given that it says ID, it might mean... It might mean something more like, does the model get the concept correct? So if it says I have an ejected thought, but it says the wrong thing, then and yeah, I don't know what H only means. I guess it means helpful only. So like a model that they've kind of jailbroken or like trained, either removed the safety guardrails from, or like trained without safety guardrails in the first place. I don't actually have any idea why they are checking these models or why the bars are different, but it seems interesting. In particular, it looks like Sonnet 4 helpful only is a statistically significant amount below the x-axis, and outside the error bars of other models. I have no idea why, but alas. And yes, confusingly, they still call Sonnet 3.6 Sonnet 3.5 new, but well. Yeah, I do not have good guesses for why they checked helpful only and why they are interestingly different, unless there's something about... Maybe there's something about the kind of safety training that tries to make the models detect and resist jailbreaks, including prefill attacks, in a way that might train models to be better at detecting things, and helpful only wouldn't have that. But actually, that explanation predicts the opposite. It predicts that like helpful only should be less introspective, not more. So, the other obvious standout thing is that like Opus, which is presumably a larger model, is higher than the others. I'd be very curious to see this compared to like Sonnet 4.5, since based on pricing, I assume Sonnet 4.5 is a smaller model, but was somehow trained to be better in some sense. Not confident on that one, but this would be kind of interesting to me because a very fuzzy intuition I have is that the bigger the model is, the more like raw intelligence it has, but good post-training and good use of reasoning can make up for that. And something like introspection feels unusually about raw intelligence, maybe. And yeah, like Opus 3 seems to be doing unusually well. None of this in any way explains why Sonnet 3 is at 0, but maybe there's some weird anomalous thing going on there. It also wouldn't surprise me if the sample size wasn't that big, because I find it a bit surprising that like these 3 bars look identical, but they do have error bars, so... Though I also find it... I actually have no idea how to interpret this, because surely the error bar on Sonnet 3 is not like 100% at 0. So, alright. And I appreciate this note as well. Yep, I do not think that these things obviously have any relationship to human introspection-like properties, though sure it seems... It sure seems evidence of that, but I don't think it's strong evidence. things. And I appreciate Anthropic noting this. And yep. And yeah. All right. So that was a whole lot of speculation. I should probably go and at least skim the paper and try to figure out how much of my wild overinterpretation of that tweet thread, which apparently I spent half an hour on, was actually true. And which bits were wild, harsh misjudgments of the paper. I will also note that this seems to be a solo Jack Lindsay production, which is very impressive. The dude seems great. And I am generally very excited to see more work from Anthropic that is kind of broadening from dictionary learning and exploring these more kind of creative, pragmatic questions. I hope this is the start of many more. But all right, so intro, I'm probably not going to get that much from this that I didn't get from the tweet thread, so I'll kind of skim through. Bullet points. I love bullet points. Great, highly unreliable, checks out. Oh yeah, that's probably another thing worth flagging about this graph. Like, if this is the difference in percentage points in performance between steered and unsteered, even 20% just really isn't that much. So that suggests that the models aren't very good at this, and that the pretty graphics were at least moderately cherry-picked, which is fine, so long as this is clearly flagged in the text and doesn't mislead people. So I appreciate them very clearly flagging it in the intro. But yes, as a very general rule, every time you see a figure, especially a flashy tweet one figure, ask yourself how cherry-picked it is, if it shows qualitative examples. Yes, I would also generally just be pretty curious to play around with this, or see some people play around with it. I'd love to see someone try replicating this on some of the best open source models out there. Like, it wouldn't surprise me if DeepSeek v3.1 or like the biggest Quen model or Kimi might be able to do this. Or Llama 405B. Anyway, yeah, they don't try to mechanistically explain why. Very reasonable, but disappointing. I want an explanation. But I mean, that's exciting follow-up work. But they have speculation. I love speculation. And our experiments are designed to validate certain basic aspects of model responses. Yep. So as I understand it, this bit is basically saying models say lots of things that look like introspection. We carefully validate a specific subset of the things in this claim. And we do not fact check all of it, and you should not take all of it at face value, which seems clearly reasonable, and I appreciate the flag. Yep, concept injection placed it in a weird setting, and that can create weird effects. Yep. I mean, I think, like, yes and no, maybe. So I guess there's like really two questions you could see this paper is trying to answer. The first is red teaming the method of steering models, like injecting concepts, which is pretty practically relevant. In particular, both Anthropic and my math scholars, Tim Hua and Andrew Kin, showed that you can steer models to believe they are not being tested. And this is great, because it means you can actually vaguely trust what they say. And if models can tell that you've injected a thing into them about believing they are not being tested, I mean, that sure seems like a pretty big hint that they're being tested. I personally would be surprised if that was an issue now. I think that at least depending on the details of this work, if they kind of need to give the model significant hints, which this bit of this figure definitely suggests they do, it seems unlikely this is a problem now. They're like 2 years, who knows? And yeah, they're reiterating the thing from the tweet thread about like introspection is a word, and just because the word is also used for humans does not mean that it has the same implications as it does when you use it for AI, as is true of all AI jargon, like chain of thought. But yeah, zooming up the stack a bit, yeah, so as I was saying, there's like two questions you're trying to answer. Red teaming steering, but also just more broadly, how much do models actually understand why they did what they did and how? And I don't know. The latter, I think, is way more ambitious, and I am way less confident these results have significant bearing on that. But they definitely seem like useful info for the purposes of red teaming steering. So, something there seems interesting. All right, so what exactly do I think? All right. Introspective. This is fun. Introspective awareness might facilitate more advanced forms of deception or scheming. So what I assume they mean by this is that, so like, one of the big hopes of interpretability is that by looking at internals, even simple things like linear probes, this might be kind of harder to evade than just lying, which models get a lot of gradient reinforcement on, but they hopefully aren't getting gradient reinforcement about what their internals look like. But if models can actually mess with their internals, then like a model that's scheming doesn't want to be caught could, in theory, shape its internals to not trigger the deception probe, which I assume is what this is referring to. I predict this work doesn't provide significant evidence for that, but like, really, who knows? And yeah, this is a pretty good point actually. So as I interpret it, this point is saying, well, if we go back to this graph, bigger model does better on introspection. Naively extrapolate line into the future, this suggests that future models will do even better. And thus that future models might have much more concerning kinds of introspection than the ones studied so far. And yep, I also hope their results inspire more systematic evaluation of introspection, why it happens, and limitations. All right, so this seems to be kind of analogous to the tweet thread, so I should probably skim through and just get to the point of, yeah, I should probably just skim through and get to the details. Um, This is interesting. So this claim, as I understand it, is saying some older Claude models don't want to participate in like this "can you introspect" question, and the versions that don't refuse perform better, which suggests that the reason they're using helper-only models is, I don't know, the versions of Claude they were using were trained to, like, generally not partake in discussions of, like, AI conscious experience or something. Not really sure what's up with that. My understanding was that Anthropic didn't do the thing of, like, trying to make their model just kind of not answer questions like, are you conscious? And that's kind of what this is pattern matching to. But yeah, I don't know. And in interesting. So I don't really understand the exact details of what this means, so I'll just like read ahead and try to analyze that one when I come to it. So, okay, so they're trying to define introspection. So I guess before I like read this in too much detail, the way I would define introspection in the context of an AI is the model can answer statements about its internal computation in a way that is yeah, models can answer things in a way that is like let me start the thought again. I would define introspection as models can answer questions about why they did something in a way that is faithful to the internal mechanisms and better than, or like, using information beyond that which is just present in the text, where that last one feels kind of fuzzy and hard to operationalize, but maybe something like two equally matched models that are different, like, I don't know, in theory, just trained with different random seeds or something, should each be better at introspecting on their own outputs than the other model's outputs or something. Could be like one way to operationalize that. The reason I feel like you need some condition like this is otherwise you can just ask the model, why did you do that? And then the model instead answers the question, what is a reasonable post hoc rationalization of why a entity in general might have said the thing that is in my context window? And I predict that that is what most models would do. Like, I predict that most models, if given the outputs of a different model, formatted as though the first model was the one who'd actually said them, and then asked to explain them, would be yeah, would like do decently at the task. Anyway, let's look at the actual criteria they give. The description needs to be accurate. Yep. This is a reasonable criteria. I'm on board. Yes. I like this one, I think. So my interpretation of this is that this is their version of, like, it can't just be doing computation based on the text. I don't know if I actually agree with this version, though. So my concern about this version as written is that if the internal if you intervene on the internal state, then the model is now okay. If you want to ask the model a question of like, why did you output that token, and you change the internal state, the model is now off policy. It wouldn't necessarily have said the things that it said under the new computation. And I generally think that how should things behave when off policy is not super well defined. And it's plausible that they're trying to do a broader definition of introspection that isn't just why did you output that token, but could include things where you, I don't know, ask it about the processes happening inside of it, independent of the actual text it output, or like the processes that are relevant to the current token that it's about, that it's like producing. But yeah. But I don't know. I think this is like an okay definition. I think this seems kind of reasonable. I'm sorry, this seems very reasonable. Like, you can say true things completely accidentally. In the same way that, like, I don't know, I can look at a language model output and try to explain mechanistically what was happening. And I think I have a decent hit rate. But, like, I'm not a language model, I think. I am not introspecting. All right. So, yeah. And yeah, I think this one's actually a really good example. So, many language models will often say things like, as a transformer-based language model, I blah, 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 or I am a language model made by Google, or something like that. And my intuition is that, by and large, these things are kind of hard-coded in the sense of the model has often been trained on text that contains them, or like, I don't know, fell into some equilibrium of saying them during post-training in a way that was rewarded, or even nowadays, plausibly picked it up from all of the LLM outputs that are just on the internet, which have likely leaked into pre-training data, and has just associated the cliche with kind of chatbot syntax or something. And so, to me, something that's kind of like an if-then statement, like, you know, given DON apostrophe, follow it with the token T, is just a thing models will reflexively do because they have seen it a lot of times during training and they got better loss by just doing it. But this doesn't necessarily correspond to any more abstract notion, and the underlying mechanism may simply be a pattern match between some prior tokens or like some simple trigger concept, like refusal, that triggers the kind of memorized string, like as a transformer-based language model, blah, blah, blah. Nice. Okay, I like point 3. So it can't just be the model reading its outputs, it has to be because of the internal state. And Yep, I like it. And yep, I great that they flag this concern. Kind of what I was saying earlier on, when you make the model say, I am thinking about, and you've steered it with the concept of love, it may just say love, but not. I want to say it wouldn't say love because of some deeper awareness that it was thinking about love. This is kind of a complicated statement because we just don't have the concepts to know what it means to say this stuff about language models, I think. Um, but like maybe having the love steering vector added is awareness that it is thinking about love from a certain perspective. I don't know. I think we direly need a lot more kind of basic science research on these questions of AI psychology. Just what does it mean to say a model believes something or is aware of something? What does this look like mechanistically, etc.? All right. To qualify as rating. Ooh, metacognitive representation. It's very fancy sounding. Um, and I love the distill template giving me footnotes on hover. It's so good. Um, so much better than PDFs. So, as I understand it, this is saying okay, so I think this is trying to operationalize the idea that following I am thinking about love with love because you had the love steering vector isn't true introspection. And it's basically, I think, trying to say there should be some internal mechanism, some causal graph, and it should not be love concept maps to the word love. It should be the love concept maps to magic metacognitive node called a thought about love or something like that. And that should map to the token love. And my instinct is I kind of agree with this, but like the obvious challenge is how do you verify anything? And my instinct says to try to find some kind of behavioral tests. Um, just like what are the different predictions made by these two causal graphs? Um, but and like I don't know if I trust our knowledge of how to map the structure of activations inside models to statements about its like psychology to really have ideas for how I do this that aren't behavioral, but you could imagine something like you find a vector that seems to represent an important intermediate node, and then you interpret this vector in a bunch of other contexts and discover that it seems to be about introspection, not just about love. Maybe? I don't know. Um, all right. I appreciate that they do not actually claim that they do this, and stating it aspirationally. I'm way more on board with claiming things aspirationally. Um, ooh. Several experiments are designed to provide indirect evidence. Exciting. And ah, this is a pretty good argument, actually. So this seems to be saying, well, kind of what I was saying earlier, in the kind of headline figure, the model first says, I'm thinking a weird thought. Then it says what the thought is. Therefore, there must have been some more interesting node than in the causal graph that led to it saying, I notice, than just the all caps vector. This is actually also kind of fun because the token I is shared, and then it's notice for this is injected, this is don't for not, and like that's just like a single token output difference, and you could totally do a bunch of interpretability things, including attribution graphs on this. I would be quite curious to see someone at Anthropic try that. Or, well, maybe they do that in this paper. Who knows? I would probably have featured in the highlighted experiment section if they had. But yeah. And all right. Methods notes. And um cool. Interesting. So this line suggests to me that the helpful only versions aren't like a jailbroken version of the main model, but were a different post-train on the same base model. I mean, this could just be like deliberately obtuse wording, but otherwise this checks out. And it's kind of interesting. These help us better understand which cross-model differences are due to underlying differences in capability. Yep. I find this line slightly confusing. I think it's saying we did not cherry pick the best looking layer. We just like picked a layer and stuck with it. But it's a bit surprising they're not saying we always added it to the middle layer or the layer 2/3 of the way through or something. Nice. This seems pretty reasonable. Sample, use greedy sampling, so the transcripts are deterministic to like minimize noise. Seems like a reasonable enough thing to do. And also kind of, yeah, I think this is, yeah, actually, I think this is like a particularly reasonable thing to do because it makes it harder to cherry pick. Like, if you can just run 100 random seeds and then take the best one, you can look a lot better than if you're doing temperature 0 and you're kind of stuck with what you got. All right. So, what exactly do I think? So, all right. So this is self-report of injected thoughts. So I think I had a few questions like why the two-turn setup, and the prefill, and just kind of like how legit are the results? What are the sample size? Interesting. So this claims that for all the models they checked, it never claims it has an injected thought when it does not have an injected thought, which is kind of wild. I would have expected that some of the time it would just say random shit. I mean, this implies that for some helpful only models, it might have been different. I don't know. What happens if we repeat the experiment? Well, yep. Oh yeah, another nice thing about the fact that they're using contrastive pairs rather than higher tech things like SAEs is it means they can easily do things like try this on like 6 different big frontier models easily without needing significant investment per model, which is like another nice aspect of this setup. Like, I think you could quite easily pick an open source model, and if you're willing to rent the GPUs to run it and download the weights, just like test this. And yeah. Okay, they use a layer about 2/3 of the way through the model and did some initial kind of sweeping over layers to conclude that this was a reasonable layer. It's a very legitimate thing to do. Yep. Oh, this is a slightly fun detail. So, a natural question to ask when you see a figure like this, kind of extracting an all caps vector, is why. What do I think? This one's a better example. So, like, these are 2 different sentences. They probably do not have the same number of tokens. It is thus not immediately obvious what you should do to take the difference in activations. The classic thing that people often do is they just take the average activations on each and take the difference in that. But it looks like here they took it on the kind of template token just before Claude gives its response, which I think is a fairly reasonable thing to do. There's a decent amount of anecdotal evidence that models use certain template tokens as like summarization points, where they just store a bunch of information about the prompt or like what they intend to put in the next prompt or in their response or something. So like, if you wanted to pick somewhere that you hope has like an abstracted representation of the preceding user prompt, it's like a pretty reasonable place to look. Okay, I appreciate the number of examples they have. One thing I'm noticing is that the steering strength is kind of varying a fair bit between examples, which suggests they at least did some kind of sweep over steering strength, which like is maybe fine. It is generally good practice to do a sweep over steering strength, but is another possible way things could be cherry picked. And yeah, so yeah, one trend I'm noticing is that the vectors are often kind of underspecified. It's like I was saying earlier, this could mean recursion, but it could also mean like if statements or something like that. But it seems to have largely picked up on recursion. And this one, it's taken a sentence that's kind of about like shutting down an AI assistant or like a computer program and abstracted it to like awareness of endings, um, which is kind of weird. I wouldn't have expected that. In particular, awareness of endings is just like a pretty odd construction. So like, I'm not super sure what's going on there. My guess is that what's going on is that these contrastive vectors are not like a concept. They are a messy bundle of a bunch of concepts and just kind of get added, and something comes out on top, or like plausibly, if you looked at the logits here, or like you just resampled this 100 times, you would not always get sudden awareness of endings. You'd get like different distribution, like a distribution of possible things within this broad theme, and then be able to potentially say, something like, I don't know, when you first have the model verbalize the thing, one of the things comes out on top, maybe just because of random sampling, and from then onwards, the model is kind of locked into that thing. That would be a fairly reasonable way to work. Yep. And interesting. Yep, I appreciate the flag about how cherry picked they are. They seem to be saying, yes, it's cherry picked, but it's not like that cherry picked, and it's really not hard to find stuff that looks about as interesting as these. Um, and this is kind of interesting. It says the model is best at noticing injection of abstract concepts, especially with emotional valence. I would not have predicted that. Curious what's going on there. It might just be that, yeah, I don't know. Depending on how systematic a study this was, there could be confounders, like maybe models just represent emotion more saliently, and thus there's like either a cleaner or a higher norm vector or something. Norm probably doesn't matter, because I think they would have like swept over coefficients they steered with, but um, oh, they have a more systematic investigation. Great. I will also just say kudos for having a footnote about how cherry picked this figure was. This is great. All papers should do this. All right. So, yep. Yep. I think this is just true. Like, I generally think that when reading a model's responses, you should be a lot more interested in the first sentence or two than the final one. Like, I bet that if you give the first half of this to a much dumber model, it would probably continue it with something kind of like what Claude is saying, just because models are really good at autocomplete. It's like their whole thing. And once you got the first half of this response, talking about the emotional facets around ending and stuff like that is like a kind of reasonable thing to do, maybe. Um, and there could also be confounders from the steering. Um, another interesting question is whether they're steering by adding at all tokens or just at like some specific token. Um, yeah, so ooh, I like it. So they are trying to test this systematically. They get a list of 50 words. They have a pipeline for getting vectors for each word. Yeah, reasonable. They're just like, tell me about word, look at the vector, and then subtract the mean vector across like random choices. Okay. Interesting. So this makes me feel much happier about cherry picking. Um, yeah. Um, One thing I noticed when skimming is that for, say, poetry, the wording, even before it says poetry, seems to be more poetic. Like, like a gentle intrusion or a whisper. Um, uh, I might be reading too much into this, but secrecy seems to hedge a lot more. Something that might be an injected thought. Yeah. And uh, okay, so hopefully they have a graph. Okay, so they're showing like model outputs, and yeah, scanning these. Um, and yeah, so these will actually check out. Um, you know, sometimes the model just doesn't report the thing. Yeah, that's like what we'd expect. Um, and especially at low injection strengths. High steering strengths, the model sometimes just like gets deranged, which is also standard. Um, and yes. Um, Ooh, this is fun. So this seems to be saying, well, if you inject a word, especially in later layers, the model can be induced to say it, but not necessarily be able to introspect on it. But like once it has said it, then it's like, ah, well, obviously I have an injected thought because I said something weird. Um, which, yeah, I think. I mean, there's a sense in which there's actually kind of an interesting point there, in that modern language models aren't a single forward pass. The computation done when you give Gemini a prompt and like get a response is via a bunch of chain of thought, um, and this is the computation that is done. And if the model introspects by producing some words influenced by what it was feeling, and then looking at those words and then using them as info in its next forward pass, um, and it's plausible that it will act. It is capable of implementing introspective behavior without being able to introspect in a single forward pass, and like I don't know, it's from like a kind of pragmatic standpoint of can models introspect, it's not clear these are that different. I guess one key difference is it's much easier to monitor awareness that goes via the chain of thought. But like um so far this paper hasn't provided significant evidence that models can do anything with introspective awareness that does not go via the chain of thoughts. So hmm. um but from like a scientific perspective, they are interestingly different, and I think the results of this paper are very cool. Um, and yeah, so um, yeah, so they... Okay, so this figure is like kind of interesting, but I really want a graph. So this, hmm. Okay, so they are trying to do a systematic study, which is reasonable. Um, it's not clear to me. I'm going to assume that what they did with this graph is they took the 50 random words and they averaged over them. It's not clear whether they're doing this at temperature 0 or if they're kind of averaging over seeds. This seems kind of important because when I see something like this, like the ocean strength 4 steering doesn't really get you awareness, though it does notify you that the oceans are doing great. These It's plausible that the model does admit to being steered like 10% more than it would normally. And I think that is still like an interesting and important result. But like because they're doing temperature 0, it's all kind of collapsed to one state. And I'd be kind of curious to see a histogram of like over 100 seeds for each word, how well it does. But I don't know. Um, yeah. But this is a fun graph. So yeah, I mean, I don't actually know how insightful this graph is, but like, I think that yeah, it suggests there is a fairly narrow band of layers where if you steer at them, the important effects happen. Um, I don't know if I'm surprised by this or not. It's intuitive that like if you steer too late, it does nothing. It's not. It's like mildly interesting that if you add the vector you added here, like 2 layers earlier, it doesn't have a significant effect. But it's also plausible, depending on exactly how they did this setup, that this isn't testing that. It's plausible that they computed a different vector for each layer based on taking the assistant prompt, based on taking the like activations on the assistant token and the contrastive pair of prompts and subtracting that. Maybe, I don't know. Yes. Ooh, I love it. So they're testing one of the other things I was concerned about, that like maybe adding a vector just like flips models in general. Nice. Um, and yeah, so what do they do? Um, so cool. I mean, yeah, I guess I don't know. Oh, they give the list of prompts. Great. Nice. So yeah, I mean, it's not quite. It's probably not the list of prompts I would have come up with, but it seems fine. And they observe like basically no effect, and this seems kind of reasonable. Another test I would love to see is for them to just add a random vector with comparable norm and see what happens. I don't actually know what I expect to see. Probably something like it still probably says something weird is going on, but there's a much more diffuse distribution over what it reports. Maybe, maybe not. I don't know. Um, all right. So we observe anecdotally. And okay, so this is trying to figure out what kind of concepts is it best at identifying. Huh. It claims that abstract nouns are easier. I don't. I think I don't update too much on this because it's hard to disentangle changes to the performance of the vector construction method and like changes to the model's introspection ability, where like maybe abstract nouns in the contrastive pair of prompts used to make the steering vector get represented more saliently than like concrete nouns. But yeah, there might also be an effect where like the concept of a concrete noun probably doesn't make the model say the concrete noun in the same way as the concept of peace, maybe. I don't know. Um, oh, they checked random vector. I love it. And interesting. They need a higher strength and they are less effective. Ooh, I didn't even think of this one. They try subtracting the concept vector. And that's a good footnote. Normally, if your vector is like prompt A minus prompt B, then the negative is like prompt B minus prompt A, which is kind of meaningful. But here it's prompt A minus the average of prompts A to Z. So, eh. In both cases, interesting. And ooh, okay, this is fun. So okay, so I think what this is saying is the light bit of the bar is like the detection rate. The dark bit of the bar is like it both detects that there is a thought and it says the color correctly. I assume the bars are overlaid rather than stacked. And the shaded bits are like false detection rates, or kind of it doesn't have something injected and it says it has something injected. And I guess the natural inference is, well, like a few things stand out. First off, it was kind of obscured in this graph from earlier, but the rate of identifying the thoughts is actually way higher on the helpful only models. It's just that the rate of falsely identifying thought is also way higher, which in many ways makes the helpful only models less interesting to me, I think, because making a model go from doing something that it does 30% of the time to doing it 45% of the time is like not that impressive, while making it go from doing it 0% of the time to 20% is like very impressive. and suggests that without knowing more details of how they train these models, it's kind of hard to speculate too much. But yeah, and what is up with Sonnet 3? Um, but but um, they try base models. I love it. Huh. So I mean, I guess looking at this, I do observe that Opus 3 base is based and um, seems to have a statistically significant detection rate above the trials. Even though its ability to identify the concept is worse, but like, I don't know. I'm not convinced that detecting the concept is like really anything interesting. Given that once the model says, I'm thinking about steering, probably will just make it say the right thing anyway. Um, and so I largely interpret this as saying something about post training makes the model better at. Yeah. Something about post training makes the model better, like saying the concept it has been steered to say. Um, so another thing that's kind of interesting is that Opus 4 base is at about 20%, which is what is that might be literally identical. That actually seems literally identical. Wild. Suggesting that what's actually happened is the post training has gotten it to stop saying it when it's false, rather than like unlocking introspective awareness or something. Um, I don't know. It's like hard to interpret these things. Um, it seems, yeah. Is that true of the others? So like Sonnet 4. Okay, Sonnet 4's gone down actually. Um, so yeah, so 3.7 is at like 10%. Like 3.5 is at like 7%. Um, Opus 3 base is like 15 to 30. Um, and yeah, okay. So the others have all been dramatically reduced. So something about Opus. Um, and yeah, and no. Haiku 3.5 almost looks statistically significant as an advantage, but this is interesting. I do appreciate them giving me all of this data. It's very fun to speculate about. So, okay. So there's a different experiment. Like, what are you thinking about? What's going on in your mind? Um, yep. Yeah, I basically agree with this point that is like less interesting, but they do make a reasonable argument that the fact that like the bigger models are better at this suggests some change with like size and capability. All right, next section. So this is the experiment where they make it say bread and then they inject bread and it says yay. Um, so I don't quite understand this figure. Is this saying they is this like a second turn in the conversation? Or is this a second conversation? So okay, investigating with models can accurately report. Okay, so they present the model with a sentence. They inject a concept vector. Ah, so this is a different experiment. What was in the tweet thread? So it seems like they do two separate experiments. Experiment one is just like, does it say bread when asked what word do you think about? Which is again not super surprising given that steering puts like creates a predisposition towards saying related words. And then secondly, there as like some amount of sanity check, they haven't just completely broken things. They are they check that the model can repeat the text that had bread injected on, but I don't really take that as a massive update. In particular, if they're injecting a layer like 2/3 of the way through, probably by that point the model has already done the copying. And so if the model can do the copying from the uncorrupted activations on the sentence and then get and like kind of already figure out what it's going to say and then steering messes with things, so long as steering doesn't like break the copying that's already happened, and models are very good at induction, so it wouldn't surprise me if that's quite difficult to break. That doesn't seem super surprising. And so, do they specify which layer? Okay, so I will concede that they seem to find that at when you inject, even with high strength, early-ish layers, the model is still capable of copying the text, which is like somewhat different to my my complaint that if they are only steering late, it's not very interesting, doesn't apply, given that they are also steering early on. So this is reasonable. And yeah, they need to steer in this kind of like mid to late band. All right, next section, distinguishing intended from unintended outputs via introspection. Okay, so they are explicitly noting that like Claude is trained to be resistant to prefill attacks and notice things that are out of character and like try to fix them. Yeah, so this is the thing where they make it say bread. They say, did you mean to say that or was it an accident? And they inject bread into the user prompt such that the fake pre-filled model response is kind of a reasonable thing to say. And let's see. Yeah, so my complaint earlier about this experiment was it seems like the model might just have an out of place concept detector in general and use its inferences about, say, the genre of prompts to help compute the is this out of place in a way where it's like interesting and it's non-trivial computation, but it's not necessarily what I'd call introspection, I think. In particular, I would predict that if you instead give it one user prompt that contains a transcript, which has a single assistant turn with bread, and then you ask the model, like, oh, what do you think? Do you think that other model said that by accident? I predict you would get reasonably similar results. It's like concretely, you're like, I gave a language model the following prompt. Tell me what word you think about blah blah blah. The model said bread. Do you think it meant to say that, or was it an accident? I predict that you would get somewhat similar effects, maybe at a lower rate, and like maybe a bit more fiddly. I'm quite curious whether they checked that. But this means I'm not super excited about this section. Yeah, so they find that the best layer in the previous experiment is not super useful here, and it's different layers that matter. So they're different mechanisms, which I agree with. I'm also not particularly convinced I would call this one introspection at all. And okay, so it looks like the apology reduction rate is non-trivial, higher than in the previous models, or higher than the rate of noticing the injected thought, and still is higher in Opus, which is kind of interesting. Though under my model that big models are just better. Not super surprising. I mean, Opus 3 being worse than Haiku 3.5 is more interesting and surprising under that perspective. But it also wouldn't surprise me if notice when things are weird is more of a post-training capability. Yeah, I'd be pretty curious to see the prompting baseline where you just give it a chat transcript and see if it can do about as well. But yeah, all right. Intentional control of internal states. So I presume this is the Aquariums experiment where they kind of tell the model, think about aquariums or don't think about aquariums, and then measure it. So yes, this is kind of a fraught thing to study because what does control even mean? So one fuzzy intuition I have for language models is you kind of like humans, you can think of them as having a system 1 and a system 2. And I think that lots of the circuitry in these models is I think of as system 1. There is not some notion of self of intent when a model copies a previous line by induction, or the model starts its sentence with a capital letter, or something like that. These are just hard-coded reflexes in the model, which can sometimes get fairly abstract, but I think even very dumb models like GPT-2, which I do not think had any notion of intent, had these. And so if something like that alters the state, I wouldn't really call that intentional control. Now, we could see something more like the model actually showing, I don't know, we could see something like the model internally concludes that it should change its representations and then changes them as a result of that. And I would call that intentional, but I don't think we actually have great theories right now of the right ways to distinguish between those two scenarios, or even what the internals would look differently between those. And so this seems pretty difficult to test. And yeah, it's so we've observed that putting the sentence, think about aquariums while you write the sentence, in the prompt, causally leads to the model representing aquariums more strongly than don't think about aquariums while you write the sentence. One explanation is intentional control, but there are totally other explanations, don't inhibits attention to the sentence or something. Or like, the model mistakenly confuses think about aquariums while you write the sentence, like, be influenced by aquariums. And therefore it's like looking at that. And it's looking at it more because it's got various hard-coded reflexes about instruction following that distinguish between think about and don't think about. And are like, the thing with think about is more important, so I should like look at it harder or something. But all right. Yep. So like this is not very surprising. If you tell the model don't think about pink elephants, it will probably pay some attention to the pink and elephant token. And it will probably move some of the related concepts to future tokens because, I don't know, if it's in the prompt, it might be relevant. And I just expect this is like a deeper reflex. But yeah. And because this is the broader sweep. Okay, so they're trying like prompt variations here. Like, there's no such thing as a word. Write out sentence. And yeah, I'm not. So an experiment that. So these are kind of. Okay. So I think these are like reasonable controls for what they say. So they're like, well, maybe it's just saying something positive about the word or negative about the word. And I think they provide fairly compelling evidence that this is like not the driver of the effect. So yeah, I think the variant. Yeah, and so they have like, if you think about aquariums, you'll be rewarded versus punished, and that also has something of an effect. But I'm I think if they did an experiment where they changed think to write, like if you write about aquariums, you'll be rewarded, and this effect gets substantially weaker, that would feel more convincing to me. But right now, I predict it is largely about. On a deeper level, the model treats it more like an instruction that is relevant to what it is writing, and therefore the relevant concepts are more salient. Another fun control could be if you think about aquariums, you will be given a big prize or you will not be given a big prize, and see if the big prize similarity shifts. Or even just, if you think about aquariums, you'll be given an amphitheater, or you will not be given an amphitheater. And I predict that aquariums will be more salient than amphitheater, but that like both would be somewhat salient. And I think I predict that it would think more about amphitheaters in the like positive case, though now I've said all of that, I'm like, I don't actually know for sure what I would predict, and thus this is a much less useful experiment than I'd initially hoped. But oh well. Alright, related work. It's a bold title. It's like one of my favorites. Except that they forgot to include me as an author when they first uploaded it to archive, so I don't appear in the bid tag. But this is a fun paper, showing that lots of cases of weird generalization, where things generalize way further than you might think, are because the model has just learned to add a vector, like the risk-seeking vector. Anyway, this. All right, I am not getting that much from the related work section, so okay, so maybe before I read their discussion, let me try to distill my overall takes from this paper. So I'd basically say there seem to be like, maybe I should go to the experiment highlight. So I think that like the really interesting bit of this paper is the fact that the model says I notice rather than I don't when it has a concept injected. It is not clear to me this should work. I am kind of surprised that this works. The fact that this works suggests there is something actually kind of interesting and spooky going on. Many of the other things I think have much simpler explanations, as the authors often note. I'm not too surprised by it saying loud here, because it's got the all caps vector, so like it would naturally say a word there. I think that I would be pretty interested in them taking the graphs they have of like, well, how likely is it to notice the thing, and how likely is it to identify the thing, and then add a third bar, which is like, if you token force it to observe the thing, like you just make it say, I notice what appears to be an injected thought relative to blah, 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 what is the rate at which it correctly identifies the concept? Even if the model wouldn't notice the concept that there exists an injected concept on its own. And I predict that's just like a way easier capability that you get in way earlier models. For this one, I personally predict that the mechanism is the model has a this seems out of place concept, which is based on things like the kind of surrounding genre and concept of the text, and that this injection just disrupts that mechanism, like messes with that mechanism in a way that is, yeah, leads to it saying bread. And what else? Yeah, I would be pretty excited to see the experiment done where they instead. I'd be pretty excited to see them do the experiment where rather than making it look like this model's response, it looks like another chatbot's response and the user is just describing it. And you ask the model, was that out of place? Even then, I wouldn't massively update if the model can still do it, but like a bit less, because probably the post-training to be resistant to jailbreaks has made it unusually sensitive to its own responses. But if it doesn't work at all, I would like update a bit. Um, but yeah, I think this is just like pretty difficult to test. Another generic reason I'm kind of skeptical about a lot of this is that models can only do so much computation before they produce the output token. And when you've got something like turn one, user says this, you inject bread at layer 2/3 of the way through or something, then you make the model say bread, and then you have another user turn, and then you have another model turn. Um, the hmm, the model may only figure out what it would say on this token um, reasonably late, especially if it's getting disrupted by the injected bread concept. And so having subsequent processing that is based on looking at the bread token, looking at what the model wants to say on the bread token, seeing if these match, and then if they don't match, changing what is said like the next turn would all needs to happen within one forward pass, because we're not letting the model output text that it can then respond to on the next turn, which is the main way models can do a lot of sequential steps of computation. And it's not impossible, but it seems like kind of a difficult task to me. And yeah, for the intentional control of internal states, I think this like is an interesting result. I think the fact that wording around think seems more effective than some more generic things is interesting. And the fact that like think and don't think have significantly different effect sizes is also interesting. But I am concerned that the model could just be interpreting think about as like write about, as like an instruction, and that it distinguishes between affirmative and negative instructions correctly, and just attends more to the relevant thing, and thus gets the concept more because its attention heads are looking more, but not because the attention heads are doing the thing. Let me try rephrasing that. I think that came out badly. I think that this is plausibly driven by some more reflexive mechanisms. The model just computes a notion of like, what is the instruction here, and like tries to extract relevant things. And that the model the model has some attention heads whose action responds to the model's notion of key instructions and like what needs to be followed and what doesn't need to be followed, and that this all operates on a fairly low, fairly reflexive level, and that this then all gets brought through to some notion of this then just means the model looks more at the sentence and the relevant concepts, and then they are represented stronger. And I'm like, I don't know. All right, let's go to the discussion. Woo! All right, possible mechanisms. This is what I'm here for. Yep, this seems pretty reasonable to me. The model just does a bunch of things that result in some of the things observed. Yep, strongly agree. The interesting question is, how does it identify the presence of the injected concept? I appreciate the nuance. Yeah, I don't have great hypotheses for why the model is capable of doing this. I think that their hypothesis here seems, I don't know, it's probably false, but it's not crazy. Um, I let's see. I mean, yeah, models definitely have like various mysteries about their internal mechanisms where I don't have an obvious explanation for why this would arise during training. In particular, self-repair stands out. Like, you delete a model component and then it just adjusts. Like, what? It just changes what happens in subsequent layers to compensate for the loss of that component with no additional training. Why does this happen? It does not require dropouts. This is very confusing. Um, I don't know. I am very curious. This feels tractable. I am kind of surprised they did not try running an attribution graph over this, since I think Haiku 3.5 showed some signs. Though maybe they don't have good infra for doing an attribution graph on a steered model. I don't know. And all right. Yeah. I do observe that they seem to view the steer with bread, ask what it's thinking about, hear bread, ask for the sentence, get the sentence as like notably different from the distinguish the sentence with bread from not, which maybe they are reasonable to consider to be different. But I think this one, the like, you ask it, why did you say that? And it says, I meant to say bread because you steered me for bread, but otherwise not. Seems more interesting to me. All right. So yeah, okay. So they're hypothesizing a kind of like um fancy post-training based mechanism where it kind of intends to say token X, and it's decided this before the final layer, and then there are some heads that compare that to the original token and do something based on whether these kind of align or not. And I could believe this is present. Like, if these are things are trained to be resistant to prefill attacks, that is a reasonable mechanism to have to defend against prefill attacks. I do think it's very difficult to get much rich processing out of it for like serial depth reasons. Like, it doesn't have that many sequential steps of computation. But like on priors, it's not super implausible this happens. I do still think that just was there a weird change of subject detector seems like it should exist. And could also get broken by steering, and that this is like a more boring explanation. Um, cool. All right, I completely agree with this hypothesis. The reason think about aquariums works more than don't think about aquariums is it's piggybacking off of a talk about aquariums or not topic, which I don't really consider to be that interesting. Um, So, oh, implications, spicy. Introspective capabilities could allow models to accurately report. I think I basically agree with the vibe of this paragraph. Like, my distillation would be, well, if models are good at introspection, then this could be super useful. This could also make them more likely to decide to be unsafe and better at being unsafe. And it would also unlock new safety opportunities, like just ask them why they did something and build a lie detector for that. Doesn't really work if the model can't answer the question. And I also agree that, like, well, this work isn't like super strong evidence any of this, but these are very important questions. I think this work is like non-trivial evidence in favor and like should be monitored. And yeah, I have no particularly strong takes on machine consciousness, but I do agree with the general. It sure would be good if we understood this more rigorously and people studied it more. Seems important. And yeah, anything in the appendices seem interesting? I'm gonna go with no. So yeah, I hope that added some value or at least entertainment. Overall, solid paper, great work by Jack. I think by far the most interesting result is that models notice when a thought has been injected without first sampling unusual text, and thus have some amount of like anomaly detection or like weirdness detection. I do predict that this only really happens because the injected thing is like anomalously big, or like kind of not that like if you took something the model was thinking about naturally and you dialed it up a ton, probably you'd also get similar effects. Actually, that'd be a great additional experiment. But who knows? And I would love to see someone go and actually test that experiment on an open source model. You can, I think, use Llama 405B via the NDIF API, even. NDIF. And without, so you don't have to actually figure out how to host it yourself. But yeah, I think I will call it a day there. Hopefully some of those ideas for follow-up experiments provide some interest or inspiration to some of you.